Hi, welcome back. This is the final part of the review for Unit 8. Let's look at this first problem on the last page. It says find the perimeter and area of the triangle. Well, the perimeter is the distance around the figure, and so that would be on the outer edge here. 9 inches plus 13 inches plus 18 inches would give you all the distance around. So for this one, we don't need the 7 inches at all. Perimeter then is equal to 9 plus 13 plus 18. And the perimeter, P, uh, 9 plus 13 plus 18, double check to make sure that I've typed in the right numbers. 9 plus 13 plus 18, yeah, is equal to 40. And so the perimeter is 40 and the units are inches. So that's 40 inches around. And for the area is equal to 1/2 the base times the height, or the base times the height divided by 2. It works. This is the same. So we can plug in our values. Our height is, base is 18, and our height is 7. And then we're going to take that and divide it by 2. And so our area, 18 times 7 divided by 2. 18 times 7 divided by 2. And that gives us 63. So the area is 63, and that is in square inches. And so that's our area for the first one. All right, number 2, it says find the area and circumference of the circle round to the nearest hundredth. Well, the circumference is 2 pi r, or pi times the diameter. But we're given 15, and 15 going to the center is the radius, not the diameter. So we're going to use this 2 pi r. And the area is pi r squared. And so here we're going to say this is equal to 2 times pi times the radius, which is 15. And the circumference then is 2 times 15, 30 pi. And this is the exact answer. So if you're asked for the exact answer, that's it. But if they did ask us to round to the nearest hundredth, and so here we can type in 30 pi and round to the nearest, it's at hundredth, thank you. So 94.2, and then the 7 next to it says that rounds to 5. So 94.25. So the circumference is approximately equal to 94.25. Double check. 94.25, yeah. 94.25, and that would be in centimeters. So that's our circumference. Our area is the space inside. This is what we're looking for right here. All of that space. The circumference was the distance around the circle. So area, we've got the formula, and we know the radius. So it's pi times 15 squared. And 15 squared is 225. And so the area is exactly equal to 225 pi. That's the exact answer. So that, if you're asked for the exact answer, that's what you put, 225 pi square centimeters. But the approximate answer, which is often more useful, is 225 times pi, and we put the value in. So 225, use the value of pi in the calculator, times that equals 706.8 and then that 5 rounds to 6. So 706.86. 706.86, and that would be in centimeters squared, squared centimeters. So that is our area, is an approximate answer. So, all right, here on this problem here, which is to find the perimeter and area. Let's fill in some of the things that we can figure out. So like 4 here, that means that this up here is 4. And if this is 2 and this is 10, that means this is that means it's 8. From here to here. That doesn't help us with this right here. So let's think here. If this is 6, then I can take this up here and say that this is 6 up here as well. And the 12, even though it doesn't look like it, this then would be 6 also, because 6 plus 6 is this 12, which means that this is 6 right here. And okay, I got it. I think I've got it. So this is 2 right here. That means if I project this over, that this is 2. We'll call it 2 right here. And then that means this is 4. And so if I go back over this way, that means this distance right here is 4. And so I've got 2 and 4, that's 6. And that means this distance here is 4, because 4 plus 4 is 8, plus 2 is 10. That matches the other side. All right. Okay. Good. Now I'm going to erase some of this to clean it up a little bit. So really what I needed to know was that this was 4 and that this was 6 and that this up here was 4. So now I can say that the perimeter is equal to, and I'm going to count up all of my 4s. I've got 1, 2, 3, 4. So I'm going to say 3 times 4 plus, I've got 10 just once, so I'm going to say plus 10, plus I've got 6, 1, 2 times, so I'm going to put plus 2 times 6. And then I've got 2, let's say 1, 2, 2 6s. Excuse me, 2 2s plus 2 times 2. Now I look at this and I think I forgot, I've got this 2 6s right here, but I forgot this 6 right here. So I'm going to go back and change this 2 times 6 to 3 times 6. And I've circled everything except for the 12. So I need to add plus 12 on the end here. Then I'm going to type all that in my calculator. 3 times 4. So let's clear this up a little bit. 3 times 4 plus 10 plus 3 times 6. 3 times 6 plus 2 times 12. 2 times 2, excuse me. 2 times 2 plus the 12 on the end, plus 12. Then I hit enter and I get 56. So the perimeter of this object is 56, and it would be 56 units, whatever it was. We didn't get the units. Had it been inches, it would have been inches. If it was miles, it'd been miles. Whatever the unit of length was. If it was meters, it'd be meters, whatever it is. So we'll just put units. And now we're going to figure out what is the area of this thing. All right. For that, I'm going to erase my circles. I'm going to take this what ends up actually being a square, because it's 6 times 6, this would be 6, this would be 6. So the area of this is 6 times 6, or 36. This we calculated was 4. This was 4. And then its length of this part is 6. And so 4 times 6, this would be 24. And then we've got over here 4 times 10, and that would be 40. And so my areas altogether, my areas would be the areas of each of those parts added together. So I've got 40 plus 24 plus 36. And so the area is 40 plus 24 plus 36. And that's 100. And so this is 100 units squared, square units. So that is the answer for this problem of perimeter and area. Perimeter, again, is the distance all the way around. This is the perimeter, like this, all the way across here and down here and up here and back here, all the way around. So you have to add up all of the sides. You need to make sure you have a length, a distance for each of the sides. And for the area, we need to calculate the areas and then add them up. And that's what we did here. All right, number 4. It says find the volume and surface area of the shape with a diameter of 12 inches and a height of 8 inches. Find your answer to the nearest hundredth, or 2 decimal places. So this is a cone. So surface area. Let's go to surface area first. Now the surface area of a cone has 2 surfaces. It has the circle on the bottom, and so that would be pi r squared. The area of any circle is pi r squared. And then we have the part of the cone part that goes around and wraps around that circle on the bottom. And that part is pi r l. And so the height, it says the height is 8 inches. So this is 8 inches. And the diameter is 12 inches. That means that if the diameter is 12 inches, the radius is 6 inches. And the height and the radius are perpendicular to each other, which means that this is a right triangle. And we can figure out, we need to know what L is. L is the slant height of the cone. And we can use the Pythagorean theorem to say, let's go over here and write this, 6 squared plus 8 squared equals L squared, the hypotenuse of that right triangle. So 6 squared is 36, and 8 squared is 64, and that's equal to L squared. And 36 plus 64 is 100. That's equal to L squared. And then the opposite of squaring is taking the square root. So I take the square root of both sides there, and then L then is equal to 10. So L is equal to 10. And now we can plug those values in here. The surface area is pi times r is 6, so that's 6 squared, plus pi times the radius, which is 6, times the slant height L, which is 10. And 6 squared is 36, so that's 36 pi, plus 6 times 10 is 60, so that's 60 pi, and 36 plus 60 pi would be 96 pi. And that is the exact answer, but we are being asked to round our answer to the nearest hundredth. So then we can just take that 96 pi and put it in our calculator. 96 pi equals 301.59. 301 So the surface area is 301.59. 301.59. And they did give us the units were in inches, and so this would be in inches squared. And that's our answer, both in exact terms as well as in approximate value. Now, the area of a cone is equal to 1/3 pi r squared times the height. And you could also think of this just like before we talked about with the area of a triangle. The area of the cone, we could think of this as pi r squared times the height, all divided by 3, and it works either way. So we can just put this in. We're going to put pi times r, which is 6, that's 6 squared, times the height, which is 8. This time, we're not going to use the slant height. It doesn't come into the formula here at all. It's just the height, and that's 8. And then all of that is divided by 3. And so 6 squared is 36. 36 times 8. So I got 36 times 8. And that gives me 288. So 288 times pi over 3. And I think 288, I can divide that by 3. Let's see. Divide by 3 goes in 96 times. So this is 96 pi. And that is the area in exact terms. Notice that this time the surface area and sorry, I called this the area. It's not the area, it's the volume. Excuse me. The volume. So notice that here the surface area and the volume are the same. Don't think that's going to be the case in every instance. It's not always going to be the case that the surface area and the volume are the same. Do not make that mistake. Okay, so that is the exact volume. And we already know when I put that in, the volume then is approximately equal to 301.59. And this time it's inches cubed because it's a volume. So we're talking about the 3-dimensional space, not the 2-dimensional space like you do with area. So it's all of the space inside that cone. And that does it. Study hard, you'll do great.